Today we will be working on SLT 15, graphing polynomials in factored form. We will look at our exponents of 2 and 1, as well as our leading coefficient of -2. Our leading coefficient of -2 tells us our graph starts here. Our exponents of 2 and 1, 2 plus 1 equals 3, tells us our function is add. We are first going to look at our zeros and x-intercepts. In factored form, we have a positive 1, which means one of our intercepts will be -1, 0, and a -3 means our other intercept will be 3, 0. Let's plot those points. Now we're going to take our graphing calculator and go to y equals. In the y equals, we are going to type in this function. We will then hit second graph. You will see a table where it says 0, 6. That is our y-intercept. We will put that here and plot the point. Now, because we know it is an add function, we will plot our other arrow here where our graph will end, and we will sketch our graph. Looking at our end behavior, left, x always is in the negative infinity. When we look at this function, we see our graph goes up, so y is positive infinity. When we look at our right, x is always positive infinity, and y on this function is going down, so it's negative infinity. Let's take a look at one more problem. This problem has no negative leading coefficient, so it is positive, and we'll start over here. We have our factored form that tells us our zeros are 6, 0, 1, 0, and -1, 0. We are again going to take our graphing calculator. If you have this, hit second, quit, click y equals, clear it out, and put in the new function. Hit second graph, and you will be given a table, and it shows us that our y-intercept is 0, 6. We will now plot these points. We also can tell if our function is positive, even, or odd by adding our exponents of 1, 1, and 1. 1 plus 1 plus 1 equals 3. So we will put our arrow going down, and we will sketch our graph. Looking at our end behaviors, we know x is always negative infinity on the left side, and on the right side, x is always positive infinity. Looking on the left side, our function goes down, so our y is negative infinity. Looking on the right side, our function goes up, so y is positive infinity. Please try the rest of these problems on your own.